Welcome to today's video lesson. On the board, we're having questions on mole concept. We're having 5 questions to practice under mole concept. Now, when it comes to questions under mole concept, we have formulas like n equals to small m over capital M. For volume, we have n equals to V over Vm. When it comes to particles, we have n equals to x over Na. So we have formulas like this for solving questions under mole concept. But I'll be using another method to solve the questions we're having on the board. So number 1 says that determine the mass in grams of 0.500 moles of calcium hydroxide. Now listen very well. When it comes to questions like this, just relate the unit in the question. And on the board here for number 1, we are having moles and we are having mass. So what happened? We are relating moles and mass. Number 1, we are relating mole and what? And mass. And everything you'll be solving must come from 1 mole. Must come from 1 mole. So the question says that determine the mass in grams of 0.500 moles of calcium hydroxide. So we are relating mole and mass. So 1 mole weighs what? So weighs what? 1 mole of calcium hydroxide weighs what? Weighs, that be equals to, so we're having number and we're having mass. So we're having calcium, oxygen, and hydrogen. How many calcium do we have here? We have just 1 calcium. How many oxygen do we have here? We're having 2 oxygen. Because 2 times 1, we're having 2. So we're having 2 oxygen here. How many hydrogen do we have here? We're having 2 hydrogen. 2 times 1 is 2. So we're having 2. Multiplied. What's the mass of calcium? 40. What's the mass of oxygen? 16. And what's the mass of hydrogen? 1. 1 times 40, we have 40. 2 times 16, we have 32. 2 times 1, we have 2. So 40 plus 32 plus 2, that will give us what? 40 plus 32, we have what? 72. 72 plus 2, we have 74 grams. So 1 mole of calcium hydroxide weighs 74 grams. So we have mass here with 74 grams. Now, what's the question now? Determine the mass in grams. Determine the mass, that be what? X gram of 0.500 moles. 0.500 mole. So what we will first multiply our X equals to 0.500 multiplied by 74 over 1. So our X equals to, when we divide, we get answer to be what? 37 grams. So our answer is 37 grams for number 1. For number 2 now, Question 2 says that calculate the mass of 2.5 moles of sodium chloride. So we are saying mass and mole. So we are relating mass and mole. So mass, or let me say mole, and what? And then mass. Mole and then mass. So 1 mole, so 1 mole. Now, since we're having mole here, I didn't convert it to another unit. I just write my 1 mole there. But when it comes to mass, 1 mole of calcium hydroxide in mass is what? 74 gram. So the same way also, I have mole here, so I just write my 1 mole. And my mass now, 1 mole of sodium chloride, 1 mole of sodium chloride in mass will be what? So we have number and mass. So we are solving for sodium chloride. So we are having sodium and then chlorine. How many sodium do we have here? 1. How many chlorine do we have here? 1. Multiplied by, what's the mass of sodium? 23. What's the mass of chlorine? 35.5. We have 23. We have 35.5. So what's next in there? 23 plus 35.5. That will give us, when we press our calculator, we get 58.5. That will be 58.5 gram. So 1 mole of sodium chloride weighs what? 58.5 gram. So what's the question now? Calculate the mass. That be what? X gram. Calculate the mass of 2.5 moles of sodium chloride, of 2.5 moles of sodium chloride. So what's the next thing here? Cross multiply. So our X equals to 2.5 multiplied by 58.5 over 1. So our X equals to, when we press our calculator, we get 146.25 gram. Final answer. So my X here be what? 146.25 gram. So that's for number 2. For number 3 now, number 3 says that a container contains 3.193 times 10 raised power 23 methane molecules. What is the volume of the methane gas at RTP? So what happened here? We're having molecule and volume. In other words, we're having particle and volume, because particle can be molecules, particles can be atoms, particles can be electrons, particles can be ions, particles can be proton, particles can be neutron. So particle we are having here is molecule. The particle here is molecule. So we are relating particle and volume. Particle and volume. So what's the question now? So before the question, 1 mole of any substance contains what number of particles? 1 mole of any substance contains what? Avogadro's number or Avogadro's constant, which is 6.02 times 10 raised to the power 23. So we have what we have here, 1 mole of any substance contains what? 6.02 multiplied by 10 raised to the power 23. The particle we are having here is what? Molecule. So we are having molecules. So what's the volume here now? 1 mole of any gas occupies what? At RTP occupies 24.0 dm cube at RTP. So we're having 24.0 dm cube. This is 1 mole of any substance containing 6.02 multiplied by 10 raised to the power 23 molecules. I'm also having 1 mole occupying 24.0 dm cube. So what's the question now? What is the volume? So we have what? X dm cube. What is the volume? So we're having a value for particle here, which is what? 3.193 times 10 raised to the power 23 molecules. So we're having 3.193 multiplied by 10 raised to the power 23 molecules. So what's the next thing here? Cross multiply. So our X equals to 24 multiplied by 3.193 times 10 raised to the power 23 over 6.02 multiplied by 10 raised to the power 23. So what's next in here? This cancel this. So X equals to, when we multiply these two, we get 24 multiplied by 3.193. So you have 76.632 divided by 6.02. So our X equals to what? So 12.73 dm cube. That is our final answer for number 3. Number 4 now. Number 4 says that what volume at STP would the following gas occupy? A. 2 moles of oxygen gas. B. 0.1 mole of hydrogen gas. So what happened here? We are relating what and what? We are relating mole and what? Volume. We are relating mole and volume. So we are relating number 4. We are relating what? Mole and volume. So here we are having mole. So we just leave it as 1 mole. We are having volume here. And we are having the volume at what? STP. So 1 mole of any gas would occupy 22.4 dm cube at STP. So you're having 22.4 dm cube at STP. So this is our relation now. What's the question? What volume? So we're having what? X dm cube would the following gas occupy? A. 2 moles of oxygen gas. So we are solving for 4A, which is for oxygen gas. So we are having 2 moles. So what's the next thing here? Cross multiply. Our X equals to 2 multiplied by 22.4 over 1. So our x equals to 2 times 22.4, we get what? 44.8 the cube. That is for 4a. If 1 mole occupy 22.4, then 2 mole will occupy what? 44.8. 4b now. We are also relating mole and what? Volume. So we have mole and what? Volume. Mole and volume. So mole, we are having 1 mole. 1 mole of any gas. 1 mole. Remember, everything I've been doing since I'm using what? Mole. 1 mole. 1 mole. 1 mole. 1 mole. So from there, I'll now solve my question. So 1 mole of any gas occupies 22.4 dm cube at what? At STP. So I will have 22.4 dm cube. So what's the question? What volume? What volume? So I'm having x dm cube here. What volume would 0.1 mole of hydrogen gas occupy? So I'm having 0.1 mole, cross multiply, x equals to 0.1 multiplied by 22.4 over 1. So x equals to what? Multiply 0.1 multiplied by 22.4, that will be 2.24 dm cube. 2.24 dm cube. That is for, this is for number 4. Now for number 5, number 5 says that find the number of particles in 1200 cm cube of nitrogen gas at STP, given molar volume equals to what? 22.4 dm cube. So we are relating what and what here? We are relating particle and what? And volume. We are relating particle and what? And volume. So 1 mole of any substance would contain how many particles? Will contain Avogadro's number or constant, which is what? 6.02 times 10 raised to the power 23 particles. So what's the volume here? My volume is at what? My volume is at STP, and 1 mole of any gas would occupy 22.4 dm cube. 1 mole of any gas would occupy a volume of 22.4 dm cube at STP. So my volume here is what? For 1 mole is 22.4 dm cube. My 1 mole for particle is what? 6.02 times 10 to the power 23. My 1 mole for volume is what? 22.4 dm cube. So what's the question now? Find the number of particles. So that is x particle in what? 1200 cm cube. 1200 cm cube. Now I'm having my value here in cm cube. So what do? I convert to dm cube. So 1 dm cube will be 1000 cm cube. So x dm cube will be what? 1200 cm cube. Cross multiply. My x equals to what? 1200 over 1000. 0 cancel 0, 0 cancel 0. So our x equals to what? 1.2 dm cube. 1.2 dm cube. So I'm having 1.2 dm cube instead of 1200 cm cube. So I'm having 1.2 dm cube. So what's the next thing here? What's the next thing here? Cross multiply. So my x equals to what? 1.2 multiplied by 6.02 multiplied by 10 raised to the power 23 over 22.4. So my x equals to 1.2 times 6.02. I will get 7.224 multiplied by 10 raised to the power 23 over 22.4. So my x equals to this divided by this. So we have 0.3225 multiplied by 10 raised to the power 23. 23 particle. Or better still, or I can raise this one here to standard form by bringing my points here. So that will be x equals to 3.225. If you are moving your point towards this way, it will be what? Negative. If you are moving your point towards this way, that will be what? Positive. So I'm moving towards this side, that will be what? Negative. But how many times did I move? I moved just once. That will be what? Times 10 raised to the power minus 1. So times 10 raised to the power 23. So my x equals to 3.225 multiplied by 10. The same base, indices. We're having the same base. So that will be what? Minus 1. This multiplication sign changes to what? Plus addition. Plus 23. So finally I have x equals to 3.225 times 10 raised to the power what? Minus 1 plus 23. I have what? 22 particles as my final answer. So that is that for these questions here. So now let me do a little bit of revision. So now for number 1, I related what and what? I related moles and what? And mass. Moles and what? And mass. My 1 mole here, I put it here. And my 1 mole here, I put it here. My 1 mole here, I leave it as mole. My 1 mole here, I converted it to what? To mass. That is for number 1. For number 2, I'm having mass here, and also I'm having mole here. So number 2, I related mole and what? And mass. My 1 mole, I put it here as just 1 mole. But my 1 mole, my 1 mole here, I converted it to what? To mass. I mean, my 1 mole of sodium chloride, I converted it to what? To mass. So my 1 mole is here. My 1 mole is here also. For number 1, my 1 mole is here. My 1 mole for calcium hydroxide, I did what? Converted it to what? To mass. That's for number 1 and number 2. For number 3 now, what did I do? I'm having molecules here, which is particles, and I'm having volume here. So I'm having particle here. I'm also having volume. My 1 mole for particle is what? 6.02 times 10 to the power 23. So I put it here. My 1 mole for volume at RTP is what? 24.0. So I put my 1 mole of volume, which is 24, I put it here. So I now applied the question. That is for number 3. For number 4 now, number 4, I'm having what? Moles and what? And volume. Moles and volume. So I'm having moles here. I'm having volume here. So what did I do? My 1 mole, I put it here as just 1 mole. But my 1 mole here for volume is what? 22.4 dm cube. So I put my 1 mole here, my 1 mole here also for volume, and now applied my question. That's for number 4. For number 5 now, what did I do? I'm having particle here and I'm having volume here. So I related particle and what? And volume. Now, my 1 mole for particle is what? 6.02 times 10 to the power 23. So that is 1 mole for particle here. My 1 mole for volume is what? 22.4 dm cube at what? At STP. So that is that about calculations under mole concept. And don't forget, do well to subscribe, like and comment so that this can be of help also to other students as well. So do the other students good by subscribing, hitting the like button and sharing to them as well, and commenting also. Thank you very much.